Hello, my name is Ricardo Goncalves and this is my public lecture analysis. This public lecture was given by John De Pilis, a mathematics professor from the University of California. In this lecture, he explained to us what special relativity was about. He used a series of real-life and also hypothetical examples in order for us to understand the concepts more easily. It is important to highlight that most of the theorems and definitions given in this lecture are complex and complicated because they involve advanced terms. The introduction. Professor De Pilis began his lecture by explaining the steps of how a physics phenomena exposition should be presented. Two fundamental questions must be asked: what and why? In the case of Galileo Galilei, he asked the question of what was happening first. He saw that heavier objects fall at the same rate as lighter objects if you ignore the air friction. And then he asked himself, why is this happening? Why is this working? And now we know why that happens. Important concepts to keep in mind in the relativity world. Linear algebraic scaffold. In the vector space, it involves a collection of objects pairwise to create a third object. Linear transformation. It preserves the linear combination and also any linear transformation. The special relativity basics. The first one is that all of the laws of physics are equally valid. There are no exceptions and all of them are taken into account. Now, the speed of light is a very important topic, and it states that the speed of light is the same for all observers regardless of the motion of the source of the receiver. In other words, the speed of propagated wave does not depend on the speed of its source. Also, another concept is that moving objects shrink in the direction of motion. And a real world example of this sentence would be when you hit a tennis ball with a racket. You will notice that at the instant of the impact, the tennis ball will shrink. But then, when it separates itself from the racket, it will return to its original state. Inertial frames. A frame describes time and space in a constant motion. It is expressed in the x-axis. Properties of inertial frames. All frames are identical when at rest. Observers within the frame are fixed. Communications between frames is only perpendicular, and relative speeds between frames are negative symmetric. Now, as I said before, all of these concepts are abstract and hard to understand, but further research will help you get a better notion of what they mean. The twin paradox. Professor De Pilis also proceeded to explain the twin paradox, which I found very interesting and made me want to further research it, because Professor De Pilis explained it with more advanced terms that I couldn't understand. So that's why I decided to make more research about it. The general idea of this paradox is that there are two twins, and one of them decides to get a rocket and travel through space at the speed of light, and the other one stays at Earth. After a certain amount of time, when the twin returns to Earth, he will see that his brother is older than he is. When I researched to find the explanation for this occurrence, I found out that the Earth and ship are not in a symmetrical relationship, and therefore the ship experiences additional acceleration, and the twinning Earth remains at the same inertial frame, while the other one undergoes a turnaround in its inertial motion. So these constant acceleration forces that the the twin in space receives is what creates this difference in h between both of them. Slinky message transmission. The professor also gave a very refreshing and interesting example about a slinky. He said, suppose you have a slinky and decide to hold it on the air and then drop it. What happens to the bottom and upper part of the slinky? Would the bottom part go up and the upper part go down, and then they meet in the middle part and then go down? Would the bottom part just go down at once? What will happen? Well, in a very slow motion video of this event, we saw that the bottom part will stay at its position without moving, and then the upper part would come down, hit the bottom part, and then they would both go down. I myself would have never imagined that that was the thing that happened. He said that this was due to the tension forces there exist in the slinky. Now I'm going to finish this video just as Professor De Pili finished his lecture. He told us a way to calculate the speed of light using only instruments and objects found at home. He said, put slices of bread with cheese inside the microwave, and then measure the distance between the holes that came out in the cheese after heating it in the microwave, and multiply such distance by the frequency at the microwave. That's the speed of light. Thank you for your attention.